Good afternoon, Year 10. Today we're going to be looking at factorising by completing the square. But before we do, let's quickly go over the factorising techniques that we learnt last lesson, which was the non-monic trinomial. So we looked at a few different techniques in the lesson, but the method that I have been using in the later examples was to use the factorising in pairs method. So to do that, you multiply the 6 at the beginning with the 6 at the end, and we're looking for two numbers that multiply to give 36, and they will add to give the negative 13 that is in the middle. So the two numbers that are going to work will be a negative 9 and a negative 4. What we do is we rewrite the question with the 6x squared, but the negative 13 will be split to be negative 9x and negative 4x. They were the two numbers that I mentioned. Then we have the plus 6 on the end. Now I factorise in pairs. So looking at the first two terms, I can take a 3 and an x out of those terms to leave 2x minus 3. The third and the fourth term, I can factorise out a negative 2, which will give a 2x minus 3. Now, the 2x minus 3 is a common factor, and the 3x and the minus 2 would be the leftover parts that we put into the second bracket. Okay, let's do that again one more time. In this next one, we have 16x squared minus 24x plus 8. Now, this question does have a little bit of an extra part to it. Before I start doing the technique that I did in question 1, I can see in this question that there is a common factor of 8 in all of those terms. So I'm going to factorise that out first because it will make my numbers much smaller and easier to manage. So that would be 8 bracket 2x squared minus 3x and a plus 1. So it is still non-monic because there is that 2 in front of the x squared. So looking at my numbers, I'm going to multiply the 2 with the 1. I'm looking for two things that multiply to give 2 and add to give a negative 3. So that would be a negative 2 and a negative 1. So we're splitting the middle term to be a negative 2x and a negative 1x, or negative x, plus 1. Now, because I've already got a bracket there, I'm going to change it into a square bracket so that I can factorise the middle part in its pairs. So the first and second term, I can bring a 2x out, which will leave x minus 1. In the third and fourth term, I'm going to factorise the minus out, which will give x minus 1. Close the square bracket. One final step is required, so I have to go sideways here since I've run out of room. The 8 is still sitting out the front. The x minus 1 is the common factor in there, which means that the 2x and the negative 1 that be in front of that second bracket goes in the second bracket. And that's it. Okay, that brings us to question 3, where we have a fraction. And whenever you are simplifying fractions, you want to factorise first. So on the top of that fraction, we have two terms with a minus sign in between. So this is a difference of two squares. Square rooting 9x squared, we get 3x. So that will go at the beginning of each bracket. The square root of 4 is 2, so that goes at the end of each bracket, and in between we need 1 plus and 1 minus sign. On the bottom, we have our non-monic trinomial. So rather than rewrite my fraction over and over again, I'm going to bring it over to the side and factorise it over here. So my numbers that I'm looking for, I need to multiply the 15 with the minus 4, so they have to times to give negative 60. And they have to add to give the 4. So that would be a positive 10 and a negative 6. So let's rewrite our non-monic trinomial by splitting that middle term. 15x squared, we're going to have a positive 10x and a negative 6x, and the minus 4 will be sitting on the end. Okay, factorising in pairs, I can bring out a 5 and an x to give 3x and plus 2. The third and fourth term, I can factorise out a minus 2, which will give 3x plus 2. So that brings us to our common factor of 3x plus 2, and the 5x minus 2 will go into its own bracket. So that now comes back to my fraction over here, and I can put that on my denominator, 3x plus 2 and 5x minus 2. And because everything's factorised, I can see I can cancel the 3x plus 2 from the top and the bottom. And my final answer would be 3x minus 2 over 5x minus 2. Okay, so moving on from there, as I said, we want to do factorising by completing the square. Now it says up here at the top, not all quadratics can be solved easily. So it says consider x squared plus 5x plus 1. If we were trying to find two things that multiply to give 1 and add to 5, we have a bit of a problem because nothing's going to work. So there are plenty of things out there that cannot be factorised, and we need to learn some other techniques to help us do these questions. So the first method we're going to learn in this lesson today is the completing the square method. We're going to learn another one in a few more lessons. When we're solving equations, we'll learn about the quadratic formula, but we're just going to stick with completing the square today. So when completing the square, what we're trying to do is we're trying to factorise something into the form of x plus some number, I'm going to say 1 in bracket square. That's what I mean by a perfect square that I want to make. So to make a perfect square, we need to introduce a constant term to the quadratic, which will help us to factorise it easily. This is sometimes called the third term or the new term. So in our little formula box here, it says new term. To calculate the new term, what you do is you halve the coefficient of whatever is in front of your x, and then you need to square that to get your answer. And that is the third term that you need to make your perfect square. Okay, so let me show you how that's done. In question 1, it says complete the square on the following and then factorise the resulting perfect square. So you can see that we only have two terms here, but we're just going to be practicing because normally we won't have equations that look like this, or problems that look like this. It's not an equation. But it's a starting point, just learning how to find that third term. So what we want to do is you need to take the coefficient of the x, which in this case is the 8. We need to halve it. Okay, so I'm going to have half of 8, and then I need to square that. That's what that formula is saying. So half of 8 is 4, and 4 squared is 16. So the number that we are after is 16. Now, if you think about your techniques for factorising monic trinomials, the things that times to give 16 and add to give 8 would be 4 and 4. Because the numbers are the same, it is simply x plus 4 in brackets all squared. Now, a little shortcut is that as long as you've found the right number here on the end, the number that makes the perfect square in your bracket is always half of that number that is in front of your x. So half of 8 is 4. So 4 is the number that I need in the bracket. Okay, let's try it again. In part B, x squared minus 5x, we need to find the missing number. So our formula for the new term said that I need to take that minus 5, I need to halve it, okay, so half of minus 5, and then I need to square it. The problem is that this is going to give a fraction. I'm not going to get a nice number like 16 like I did for the last one. So if you were to halve minus 5, you're going to get negative 5 over 2, which we're going to square. Two negatives make a positive, so the minus signs disappear, and we're going to get 25 over 4. Now, you could do it as a decimal, you could do it as a mixed numeral, but the improper fraction is actually easier to use in a lot of ways that will be coming up later, so that's how I like to leave it. So I'm going to put plus 25 over 4 as my third and new term that I need to add to that expression there. Now to factorize it, that will factorize perfectly into a set of brackets with a square on there, and it will be x minus, and the number that it needs to be is half of that minus 5, which is 5 over 2. Okay, so as I said, that was just a little bit of practice, but that's not really the kinds of questions that we normally associate with factorising by completing the square. So let's have a look at question 2. Factorise the following by completing the square if possible, because even completing the square doesn't work for everything. So you see that we now have our 3 terms in our quadratic. This is what we would expect, right, in our topic of quadratics, 3 terms. So what we want to do is we always want to start with the first 2 terms, x squared minus 6x. Now the minus 2 that is there is the wrong number. That doesn't factorise in the normal non-monic technique that we use, and it doesn't make the perfect square that we want to use for completing the square. So for a minute I'm just going to ignore the minus 2, and I'm just going to take those first 2 terms and use my new term formula to find the missing number that I need. So I'm going to take this minus 6 and I'm going to do half of the minus 6 squared. Now half of minus 6, that's minus 3. Minus 3 squared is 9. I want to add a 9. That's the number that I want. Now notice that these are not equations. I can't just add 9 in. I'm changing what this thing is equal to. So what I do is I straight away subtract the 9 back off again, and I put my minus 2 that was in my question, I put that sitting on the end. So plus 9 minus 9 means I haven't really added anything to my expression, but these first 3 terms, so I'm going to put brackets around them just to group them. The brackets aren't actually meaning anything at this point, but those first 3 terms are making a perfect square. The minus 9 and the minus 2 on the end, they're going to be sitting separate. Okay, so let's now factorise the perfect square part. So we're going to have a set of brackets, all squared, and we're going to have x at the beginning, and half of this minus 6, which is minus 3, will go inside the bracket. The minus 9, minus 2, I'm going to collect those up to be a negative 11 on the end. So I have succeeded in making a perfect square, but that is not completely factorized. What we have here is a difference of 2 squares. We have a bracket squared minus something else, which is not ideal. We can't square root 11 nicely, but we can put it in surd form, and we can do a difference of 2 squares with this. So to finish it off, we're going to factorize this into 2 big brackets. The square root of x minus 3 squared is going to be x minus 3 at the beginning of each bracket. And then the square root of 11 is unfortunately square root of 11, not very nice. And we're going to have 1 plus and 1 minus in between. That's the difference of 2 squares. And so that is a completely factorized version of that starting expression. Let's see if we can do that again for part B. So let's follow the same process. What we do is we start with the first 2 terms, x squared plus 4x. I need to find the number that makes the perfect square. So I take the 4, I want to find half of 4, and whatever that is, I need to square it. So half of 4 is 2. 2 squared is 4 again. So I'm going to add 4. So that I'm not changing the value, I'm going to subtract the 4 back off. and put the plus 10 on the end. The first 3 terms make a perfect square. So next I'm going to factorize this to be x in brackets squared, and the number that goes in the brackets will be half of the 4, which is a positive 2. Now on the end, the minus 4 plus 10 makes a plus 6. Now in the last question, I was then able to factorize further using the difference of 2 squares. This question, unfortunately, I have got a plus sign between my 2 terms there. So unfortunately, you can't do a difference of 2 squares if there's no minus sign. So this is something that we cannot factorize further. So that's where the if possible comes into the question. We were able to get part of the way, but we weren't able to completely factorize because there was no minus when I got to this point of the question. So I'm going to put a little note here. I'm going to point to this and I'm going to say cannot factorize further. So I was able to partially factorize with the completing the square, but that is not completely factorized. And I can't completely factorize it. All right, going to part C. Let's hope we have better luck with this one. Let's give this method another go. We're going to keep the x squared and the 10x. We are going to take that 10 and we're going to half the 10 and square it. Half of 10 is 5. 5 squared is 25. So we're going to go plus 25, but subtract it back off again and put the minus 4 on the end. The first 3 terms make a perfect square, which will factorize to be x plus 5 in brackets all squared. Minus 25 minus 4 is minus 29 on the end. So because I have that minus sign in there again, this time I can complete the factorizing by doing the difference of 2 squares. So 2 big brackets. The square root of x plus 5 squared is x plus 5 for the beginning of each bracket. Then square root of 29 will go at the end of each bracket. And then we'll have 1 plus and 1 minus in between. Okay, so hopefully you're starting to get the hang of this completing the square method. Question 3 is still asking us to factorize, and we would need to use completing the square again. The problem is that there are going to be some yucky fractions in here. So the technique is strong and will be the same, but you will have to deal with fractions in this one. So let's get started. The first thing we do is we're going to take the x squared and the 3x, the first 2 terms. We're going to take the 3 and we're going to halve it and square it. Now half of 3, don't go to a decimal, half of 3 is 3 over 2 squared. Squaring it means you square the top and square the bottom, so it becomes 9 over 4. Okay, so I'm going to add 9 over 4 and promptly take it back off again so that I haven't changed the value, and add the 3 over 4, which was in the original question, on the end. The first 3 terms are making the perfect square. So we're going to factorize them. It'll be x plus, and the number that we need will be the half of 3, which is the 3 over 2. So 3 over 2 in brackets squared. The number on the end, we have minus 9 over 4 plus 3 over 4. So they are on the same denominator. Minus 9 plus 3 is minus 6 over 4. Minus 6 over 4 does simplify to 3 over 2, but knowing that I'm going to have to square root them, it's nice to have that 4 on the bottom because that will square root nicely. So I'm going to leave it like that, and I suggest that you always leave them in that form as well. So we can continue with our difference of 2 squares. Big brackets, in the beginning of each bracket, we're going to have x plus 3 over 2. And then we have to square root 6 over 4. Square root of 6 has to be written in third form, but the square root of 4 is 2. So that makes a nice number on the bottom, which is why I left it like that. Square root of 6 over 2. One bracket needs a plus, one bracket needs a minus. Now, as an extra, you can see that these numbers in my bracket, for both of them, have a common denominator of 2. So it would be better to write this as x plus 3 plus root 6 all over 2, to push those common denominators, those fractions with the common denominator, push them together. And then for the second one, it would be x plus 3 minus root 6 all over 2. Okay, so there's one more question here, and this would be my little bit of a challenge question. We want to factorize 3x squared minus 24x plus 6 by completing the square. Now, you never want to use the completing the square technique when you have got a number in front of your x squared, because you'll have all sorts of trouble trying to make a perfect square with a number there. So the first thing you do in this situation is factorize the 3 out, even if it means that you have to go to fractions inside your bracket. So that would leave me with x squared minus 8x and plus 2. Okay, now this 3 is just going to stay sitting out the front, and I need to do my completing the square with the quadratic that is inside my bracket there. So I'm keeping the x squared minus 8x. I'm going to take that minus 8. I need half of the 8, and I need to square it. Half of 8 is 4. 4 squared is 16. So I'm adding 16, taking off 16, and putting the 2 on the end. The first 3 terms are my perfect square. So I have 3. I'm going to change my outside brackets to square ones just so they look different. And the perfect square would be x minus 4 in bracket squared. Half of that minus 8 is minus 4, so that's the number that goes in there. Minus 16 plus 2 is negative 14. And now we can do our difference of 2 squares. 3 sitting out the front, big brackets. At the beginning of each bracket, we will have x minus 4. And at the end of each bracket, we're going to square root 14. And we'll have 1 will be a plus and 1 will be a minus. And that's it. We're now ready to do exercise 8E.